Hi, I'm Greg. Welcome to my channel. I'll be making a belt grinder over the next several weeks, following Phil Vandelay's excellent plans. Phil's in Europe, so his plans are naturally in metric. His plans are for a 75 by 2000 millimeter belt grinder, which is roughly 3 inches by 78 3/4. And I'm going to be making mine the more typical 2 by 72. So I'm making tweaks as I go along, and I'll share the changes that I make, and of course I'll share them with Phil in case he wants to publish them. Today I'm going to be doing the VFD enclosure, the wiring for that. But I thought I'd start off just showing the materials I've collected here. Got stuff laid out on my garage floor. So here is the 1/2 inch plate. It's all mild steel that most of the grinder will be made from. I've also got some 3/4 inch mild steel that I'm going to build the table and platen from, a little thicker. I've got a couple of pieces of angle iron for platen attachments and so on. Some 1x2 steel for some of the clamping mechanisms. A whopping 1.5 inch piece of stainless steel for the main rod, and I'll whittle that down for the smaller rods for the table attachments. I decided to buy rather than build, make my own wheels. You can buy these things on eBay relatively cheaply. Phil's wheel is a whopping 7.5 inches or more for his design, but because I'm using a smaller belt, I'm going to use a smaller wheel. So this is a 6.25 inch drive wheel, a 4 inch tracking wheel, and two 2-inch idler platen wheels. And the bolts here are the axles for them. The rusty bit of metal in behind here is a 2x2 square tubing with a whopping 1/4 inch wall thickness. I'm going to use that as the main rod, the main attachment rod in Phil's design, as well as for the grinder base, the grinder base. I've got the usual ratcheting levers here that call for in the plans, the pull-out indexing things, the ball indexers, and then for electronics, I've got a 1.5 volt, 1.5 horsepower, 3-phase 240 volt motor. Again, I'll link to all the stuff below. And the VFD is for a 3 horsepower. Now this is an important thing I want to point out. I'd actually ordered a 2 horsepower VFD for my 1.5 horsepower motor, which I thought was plenty. But I happened to cross a channel by Adam Dubowski's, Adam D. And he pointed out that if you're running single-phase power, you actually need to double your VFD capacity. I did a quick Google search, and the actual number is 1.73 times. But anyway, you need to have a more capable VFD than you think. So 1.73 times with that 1.1 kilowatt, 1.5 horsepower motor requires, and this will be enough at 2.2 kilowatts. And then I've got the stuff, this is basically following along James Clow 42's VFD construction video. Except I'm using 240 volts, so I need 2 of everything. It's two lines, right? So I've got a 2-pole breaker, a 2-pole contactor, and a 2-pole fuse holder for some fast break 10-amp fuses. James also recommends, and I'm following along, using this EMF filter and some chokes on the line. So that's everything there. The enclosure itself is a 10 by 10 by 6, which is plenty big, I found. There'll be a fan on the top with a filter and a filter to suck in air on the bottom. Oh, and a little 12-volt wall wart to supply power to the contactor. The wires, I've got this, that's a 10-3, they call it a dryer whip, I think they call it. It's the cheapest way to buy a wire and a conduit of this capacity. And I put a NEMA 240-volt male on the end of it. And then I've got, oh, the camera's doing crazy things. Then I've got this 12-4 wire for the motor connection with a cable gland on it. And finally, this finer wire is just 22 gauge shielded 8 contactor. I think I need 6 of those 8 for the control box, low voltage. And there's the little control box that's going to mount on the grinder itself, with a forward back switch, potentiometer for the speed control, a couple of indicator lights, and emergency off. So I think that's it for the parts. Ready to get building. Oh, I wanted to show too, this project actually started about 3 weeks ago. Obviously I needed a place to put this grinder. It's going to be pretty large, and I wanted to keep it as far away as possible from my mill and lathe, which are over that corner of the garage. Typical 2.5 car garage here. So conventional wisdom is keep your grinding dust away. I've got a little bench grinder and polisher over there in that corner, far away. And then I wanted to put my belt grinder here, but in this corner here was a big, huge tank water heater, electric water heater, taking up this whole space in here. So my first job about 3 weeks ago was to convert that, take out that tank heater and put in a tankless heater here, which was a bit of a project on its own, I won't go into. And then I also gave a 240 volt outlet here for the grinder that's eventually going to live down here. And then I reused the original wiring for the tank heater, converted it to 120 back at the box, so I can put a little outlet in there. That outlet lets me plug in my powder coating system here, and a little oven, and a little light overhead here, with one to spare. And then finally I've got this bench down here now, and the bench is on wheels, so I can wheel it out if I want to. That's where the grinder's going to live. Okay, here we are now over on the bench, showing a vertical view of the whole setup here. This is a 10 by 10 by 6 inch deep box that has a solid lid. I may cut a little opening in here to put a plexiglass to be able to see the display readout, but I probably won't. It's not that important. This VFD panel is actually also removable. You can remote mount this thing, but then you need a 10-pin connector, and it's just not worth it. I don't plan to use these controls at all. They'll be all remoted. So here's the box, the VFD approximate setup there. It has a fan on the top of it, a small fan, and then I'll vent the whole case with this bigger 12-volt fan, blowing air out the top, sucking air in the bottom. So a filter on the bottom here with the cutout, and a filter on the top. And then here's my DIN rail with my 3 units on here. I've got the circuit breaker, the contactor, and the fuse block. So the idea is the power is going to come in the side here. This is going to mount on the wall. Power is going to come in the side, my 240 volt. Go into the top of the breaker, out the bottom of the breaker, in the bottom of the contactor, out the top of the contactor, in the top of the fuse block. And that's important because as you pull these fuses out, you want to break that contact first. So in the top of the fuse block, then out the bottom of the fuse block, then to this EMF filter, and then finally to the VFD input power, which connects to the R and the T for single phase. The S is not connected. There'll be a common ground, all these things connected to the ground on the ground's lug on the box here. And then for the motor out, it's ground plus UVW. That's the 3 phases of the motor. And on those motor connections, James Clow again recommends putting some chokes on it to remove some more EMF. Okay, so that's it. So we'll start making holes. So this little wall wart has to go in here as well. It's a 12 volt DC 1 amp wall wart for the contactor. James Cloud pointed out on his VFD thing that you can use 1/4 inch connectors that you can force them onto these prongs. Then I can put some heat shrink over top to protect them. This can be 240 or 120 input, so it's obviously going to be 240 here. So basically I'm just going to hook up some wire here now so that I can use this wall wart to power my contactor. And so there's a completed unit. Ready to be installed. I'll probably just use two-sided tape to stick it on there. So looking at the VFD control wiring diagram, ins and outs, and the rainbow of colors I have in my 8-wire control cable here, I just need to assign things now and figure out where I'm going to put them on this low voltage connector bus. So I certainly need I want a 12 volt out for an indicator light to say yes, it's running. I need the 5 volt out, 5 volt in, and ground for the potentiometer. That's what's going to control the speed. And I need forward and reverse. And probably I'll run reset down there too. Not sure I need it, but I've got extra wires, I'll run it down there. And that'll leave me a few extras. There's a relay here that I might make use of sometime in the future. But for now, I'll just make myself a little color scheme here and wire up what I think is necessary for my control cable. Okay, I've got the plan here, and I'm just going to repeat it for my own use in the video later. Written it down. Obviously conventional green for ground, and also at the case end here I'll wire the shield. There's a shield wire here to ground directly. At the other end, at the control box end, I'll leave it unconnected so the shield won't have a ground loop in it. For plus 12 I'll use red. For plus 5 I'll use orange. That's the out. For the 5 volt in, which controls the frequency, will be yellow. And then forward and reverse will be blue and brown for like sky and ground. Forward and reverse. The reset wire, I'll use the white one. And that will leave me the black one for something in future, or unconnected for now anyway. Okay, I put ferrules on all those little control wire connections, and I made a few other small tweaks. I did hook up the black wire with the ferrule. I decided I'm going to put that to the relay out in case I want to use it at the other end sometime. For now it's not going to get used, but I'll hook it up at this end. And then for the fan, I hooked the fan up along with the other grounds here to the common ground, so it'll come on when the VFD comes on. Likewise, the 12 volt from the fan to the 12 volt output. So I forgot to mount the EMF filter here on the wall, so I'm just doing that now. I center punched a little location there, the bottom hole. I'll drill it out, put a screw in there, and then I'll do the top hole. So I've installed the EMF filter on this wall with M4. I'm about to put down the DIN rail here with M4. It's a real tight spot on the side there. I couldn't get my fingers down there with a nut. So this little trick there is I put some scrap wire, some thin copper wire in there to jam my nut in the spot there, and I'll be able to feed it in this way. This is not a magnetic socket. Assuming this is long enough. Yeah, it is. So yeah, as long as I get the nut started, then I'm okay. And if I pull it off, it'll take the wire out with it. And that's exactly what it's done. So I think now is a convenient time to hook up all these grounds at the common grounding point here in the box. So I've got the ground from the power coming in, 240 coming in. I've got the ground from the motor going out. I've got a ground from the EMF filter, and I've got a ground from the VFD, which I haven't put inside the box yet. But okay, I eventually got that ground cluster all connected there. It wasn't too terrible. Again, it was just that one stiff wire that caused all the grief, but got it in there, and it looks nice and neat, and it's all solid. So next I'm going to put the VFD in place and connect its power inputs and motor outputs. So let's do that. So everything's wired power-wise. Now I've got the control wires. This is sitting where it's supposed to sit, but it's not fastened down yet. And I realize that it's going to be easier to get these control wires in with this thing raised up a bit too. So I'm just going to prop it up on a block of wood here or something so I can have access and hook up these control wires. So as I'm about to hook these up, I realize I've made a mistake, a stupid mistake. Yes, this 12 volt from the VFD can power the fan, but it's not the 12 volts that I want going down to the control unit on the grinder down this cable, because it won't be on if the VFD is not on. What I need is the 12 volts from my wall wart going down to the control unit so that I can give 12 volts back up to the contactor. And that's what I was going to use this black wire for. Now I recall. So quick fix here. I'm just going to cut off this red from here and hook it up to the wall wart instead and find a place to mount that. All right. So in order to give myself power to the wall wart, I'm having to remake the little short wire connections between the breaker and the contactor to include the wall wart. So the wall wart will get power out of the bottom side of the breaker. So that power comes in the top side, the breaker controls it out the bottom side. The wall wart will be powered all the time the breaker's on, basically all the time it's plugged in.
Unfortunately, my camera battery died as I was plugging in my connections to the control panel. So here's a close-up picture with some animation showing each wire and its color and its connection. So you can pause and rewind and play this back as often as you'd like. Here's another very simple animation showing how the 240 volt line in goes through the breaker, out the bottom, then into the contactor and out the top, and then in through the fuse block and out its bottom, and then it will go on to the AMF filter and then onto the VFD, of course.
I've relocated my enclosure, my VFD enclosure, over to the workbench where the grinder is going to live eventually. So I've got my 240 volt power right here. I've got the motor over here as well, and I've hooked it up to the 3 phases from the VFD. I didn't hook up the ground yet. Just a quick test. I don't want to commit to my actual junction box here yet, which hole I'm going to punch until I get it on the grinder and see what the orientation is going to work out best. So it's just temporary wiring still. So for a first test, I'm going to turn off my breaker. I learned that green is off on this breaker. It's kind of weird. Green off and red on. But there's the breaker off. I've double-checked, triple-checked my connections. And I'm plugging it in to the 240 volt. No smoke. Everything looks good so far. Everything's quiet. Turn on the breaker. Again, everything's quiet. Yeah, I wouldn't expect to hear anything yet. So on the control cable, all I've done is strip my red and black wires here. The red wire comes directly from the wall wart power, so it's 12 volts, and the black will return that 12 volts back to the contactor. The other side of the wall wart is hooked up to the contactor, so that'll complete the circuit and should then energize the VFD. And so here we go. Cautiously. We have power. The VFD fan came on briefly, then turned off. And then the case fan came on, which is driven by the VFD. So I guess the VFD has a thermistor for temperature sensing, knows it doesn't need to be on, its internal fan, but it's turned on its 12 volts, and the fan is exhausting, and it's nice and quiet. So I'm liking everything so far. Now, I haven't done the parameter settings in the menu here to change it to remote control on the wires. Quite intentionally, I've got nothing here hooked up. I got to hook up a potentiometer and switches and stuff. So for now, this control panel is still controlling. So let me put that down and try running this motor. Whoa, and we have some power. And there's 50%. And slow down. And try reversing the other way. And we're reversing. Run it at full speed this time. That's nice. That's close to 3,000 RPM. I think it's 2,800 as the math works out. Plenty fast and nice and smooth. Shows quite a lot of air from that fan, built-in fan. But all's good. The VFD's internal fan has come on now to cool it, as well as the case fan, so I think all is good. Let's hit stop. VFD still internal fan on. There we go, it's gone off now. Case fan still on. So now if I turn off the contactor, I heard a click, but the VFD has still got power. That's just its capacitors discharging. Oh, now it's saying low voltage. The case fan is still running, which is interesting. And now it's lost its power, so that's how long it takes those capacitors to discharge. So I think that's great. Everything's a wrap. I think I'm going to wrap up this video. I think it's been long enough. All I have to do is do the programming for this thing and do my remote control unit, which I think I'll save for another video. Okay, well, thanks for joining. Thanks for watching. And I hope to see you soon. Bye for now.